Hello, I'm Binny Buckley, the Kent Area Manager of the Environment Agency, and I'd like you to look at this CD-ROM because I think you will learn a lot about the challenges we've been through in restoring the River Darent. Going back to the 80s and the early 90s, the River Darent was dry, parched, and virtually dead in some parts, with the ecology really wiped out. And it's one of our greatest success stories that since we separated from the water industry, we've implemented an action plan that has put flows back into the river. It no longer sees its drought conditions, and we're seeing not only the insect life coming back, but actually the very important fish that depend on that. Well, when we started this exercise, we realised that it wasn't just the river life that was important for the Darent Valley, it was how important it was as a national treasure. And we consulted people who lived in that area, and they told us what a wonderful recreational facility it was, whether you're walking your dog or fishing or just generally enjoying the amenity. And the response was, this is a national treasure and it's well worth the investment to restore it. CD-ROM's got film footage, photographs, diagrams, and they help us understand what the issues were. But far better than that, it helps us understand some of the quite technical issues that led to its restoration.
And what kind of people would find this useful?
I think it will be useful to anybody in the locality who's enjoyed that beautiful valley, and it's within close reach of a massive population. It will help people who want to know about the water environment, the wildlife environment, schools, teachers, and really anybody in public service who thinks that they've contributed or could contribute to another scheme of this nature.
The River Darent rises in the Weald of Kent and flows for about 35 kilometres through the North Downs towards the Thames. For much of its length, this is one of the most picturesque areas of southeast England. But the valley also has a long history of development, with its Roman villas, medieval castles and former water mills, and now modern agriculture, urbanisation and industry. The groundwater from beneath the River Darent and its tributary, the River Cray, has long been heavily exploited. Most of the water is taken for public supply, although some is used for irrigation and industrial needs in the lower end of the catchment. Because of these abstractions, the groundwater table has dropped below the river level, and due to leakage through the riverbed, the average flow has been reduced by 60%. Here at Hawley, near Dartford, for example, the average discharge of water is only 43 million litres a day. But if abstraction was not taking place, this average flow would be more like 107 million litres a day. This chart shows the theoretical natural flow, and this is the actual flow after abstraction. And during the worst droughts, the river effectively dried up, particularly in the heavily abstracted stretches in the lower Chalk Valley. And the reduction in groundwater levels also affected the shallow fishery lakes adjacent to the river. A survey by the agency's predecessor, the National Rivers Authority, found that the Darent was more environmentally damaged by abstractions than any other river in England and Wales. But what does this actually mean in practice?
Well, the most obvious environmental impact on low flows in the Darent has been when the river has disappeared completely along certain stretches. A dry riverbed, in fact so dry that in the past the locals have used it as a car park. Now that's a very obvious impact, a riverbed with no water. But we also see at lower flows the fact that the water doesn't carry the silt away, the channel becomes narrower, it becomes adjusted to having lower flows in than it would expect to have naturally. That adjustment means that you end up with different sorts of vegetation coming in from the bank and invading into the edge of the river, also then making the river narrower. You get a different set of insect life living on that vegetation, and that shows that the species which are key to giving an indication of very good health of the river, they begin to disappear. As the vegetation changes, so the insects change, and the mud at the bottom means that you don't get the very good indicator species of a fast-flowing chalk-type stream. The river was well known in the 19th century as a trout fishery, The low flows meant that the habitat that's available for those fish has disappeared. The flows are too low to support the spawning and the whole life cycle of what the fish require. The fish have retreated from these areas in the middle and lower reaches of the Darent. We still have some populations in the headwater, but they're finely balanced. What we need now to do is to get the water and the flows, the velocities and the habitats back to the level where fish can be supported.
Alan Williams, currently chairman of DRIPS. Been associated with the river for many, many years. My first concerns of the river was in early 1970s, when we saw at the lower end of the Darent the river drying and the lakes along its length also drying. It was a very sad day for us all. We then tried to pressure Thames water just as individuals, and that didn't work at all. In 1985, DRIPS was formed as a result of a meeting called by the Shoreham Society and the Shoreham District Council. We met in Shoreham Village Hall, and there were delegates from each of the parishes and also interested parties such as the fishermen, environmentalists and so on. And a committee was formed. And from there our stated aim was just to get the River Darent restored and its future secured. A lot of work went in by that committee and the then chairman, Darent Atwood, and we did in fact manage to get nationwide press coverage, also television coverage, and that was really what gave DRIPS its strength. Managed to negotiate with then, I think it was then the NRA and the water authorities, that the Darent Action Plan was formed. Darent Action Plan was in two stages. Its first stage meant cutting down some obstruction in the headwaters of the Darent, drilling artificial wells, and also these weirs that you could see along the river now, all designed. Stage one was, in my view, partially successful. And we see the results of stage one today. And that is healthy, but it also demonstrates that stage one or phase one just wasn't sufficient. And we're now involved with phase two. Phase two hopefully will go ahead, and it's DRIPS' duty now to ensure that phase two is completed and the Darent restored.
My name is Michael Mansell-Mullin, and I've been a hydrologist all my life, working largely overseas, but the last 20 or more years in this country. In the mid-80s, chalk streams were being recognised for the first time as being seriously depleted by public water supplies. And I worked on 3 or 4 rivers in Wessex initially. And then in 1986, Darent Atwood, who was the first chairman of DRIPS, just at the time it was being formed, asked me if I could help. And I have been involved with DRIPS ever since then. So that's now 16 years, quite a long time. The Darent, of course, in the past and hopefully in the future, is a beautiful river and a beautiful valley. And I felt it a very worthwhile job to help as much as I could in restoring it. When the DRIPS was formed, there was initially not very good relationships with the water companies, as could be imagined. And perhaps the first thing which I tried to urge DRIPS to revise, to change, was their relationship with them. And I said that if they weren't going to work closely with the companies, then they wouldn't get anywhere improving the river. Unfortunately, this was taken on board quite quickly, and ever since there's been an excellent relationship, both with water companies then with the NRA, and now with the Environment Agency. In the early days, there were a collection of reports done, several batches of them, by different consulting firms. The first ones weren't really very satisfactory because they weren't given a sufficiently broad terms of reference to be able to examine the whole catchment and to look at all the problems and to take a really broad view as to how the river might be improved. With time and experience, the different terms of reference, the subsequent consultants were able to put forward plans which are those which are now being implemented. It was to be in two phases, and the phase one was completed some years ago and has definitely helped the river. Phase two, which is now in progress, has still got another 2 or 3 years to run, and until it has been in operation, which is still further into the future, we won't really know how successful that has been. But there has been an enormous amount of investigation, computer modeling, field trials carried out over the last 10 years. And although these studies are very difficult and not entirely precise, I'm pretty sure that when it comes to the scheme being completed, that it will be successful. One of the things which I also heard was that there needed to be a clear aim as far as the condition of the river was going to be concerned. Not just flows, because flows in themselves are not all that meaningful. It's the condition of the river in terms of the flora and the fauna and the environment, people's perceptions of the river, whether they walk along it, recreational use. It's the whole spectrum of different aspects. And this has, particularly under the Environment Agency, been taken on board, and the studies which there are carried out have been very comprehensive and have covered all these environmental aspects. The present day, the word biodiversity is very popular. It's rather difficult to know exactly what it means, but it's an in phrase. It does cover all aspects of the river and the river life and the natural life. And these are all now being looked at, and I'm sure that although the river will never return to its previous state, it will be in a state which is an acceptable compromise.
My name is James Alexander. I've been in DRIPS ever since it first started. Currently I'm Vice Chairman, and I farm in the Ainsworth Valley. So the river means a lot to me. We love our river. It's a beautiful river. We like to see it flowing all the time. In 1976 it dried up here, and I think that was the first time it dried up. Well, obviously it dried up because there's so much water extracted from the ground, not from the river as people think, and that's why we came low, and that was DRIP's purpose, to try and stop this over extraction and get our river level back up, which it has done, which we're all very pleased. We do not like to see our river bone dry as it was in 1976. Thank goodness that's in the past, and with DRIP's help and the real people who joined together and made an effort to keep the water up. I have my own rain gauge, which I started in 1949, and I empty that twice a day. Still doing it, and I follow the rain every year. It goes up and down. There is no perfect picture. People say, what's it going to do next year? You're going to be the same as last year, but it varies all the time. Now, say I farm in this area, the water does affect us to a certain amount, but not too serious. We farm from the far end, the west end of Ainsworth Parish, and go right through to Farnham, all out the valley. My grandfather came here in 1892 with my father, who was 9 years old, and we've been farming in the same place all those years. And we hope we can still keep farming. My two sons, they've taken over from me, things are very difficult in farming, but that's the way things go. But the river keeps flowing and we're going to keep going forever.
By the early 1990s, the total authorised abstractions for public water supply from the Darent catchment had reached 158 million litres a day. Since 1996, these authorised limits have been reduced by 27 million litres per day. However, the actual volumes taken were less. On average, only 110 million litres a day was abstracted. That's a little more than 70% of the original total. But even this reduced amount was still too much for the river to sustain. About half this abstracted water is exported away from the valley and used elsewhere. The other half is used locally, but even after use, this does not return to boost the flow in the river. It passes down the valley in a trunk sewer. In the early 1990s, the National Rivers Authority carried out joint investigations with the water companies and the Darent River Preservation Society. The aim was to identify possible measures to rescue the river. The additional flow required was calculated at 35 million litres a day. An economic analysis also confirmed high social and commercial benefits from restoring the Darent. So collaborative works with Kent County Council's Countryside project commenced to enhance the ecological and amenity value of the valley. At Ainsford, 6 weirs were constructed to conserve low flows and improve amenity locally. The Environment Agency's sponsorship of the County Council Countryside project resulted in numerous improvements: footpath access, riverbank maintenance and land husbandry. In 1993, an action plan was approved by the government to achieve the target flows as well as safeguarding public water supplies by reductions in groundwater abstraction and the augmentation of low river flows.
One of the steps that the agency's taken is to introduce artificial recharge to the river, using things like these artificial springs. This is where water's pumped up from underground and pours from the borehole into the river to supplement or augment the flows. That's had a very important effect over the last couple of years where we've had droughts, 96 and 97. And it's got us nearer to the target flows that we want to achieve, but it hasn't achieved the answer. These help, but they don't actually solve the problem. The question is whether these artificial springs are sustainable. What these waters are being pumped back in is water that's leaked away through the riverbed. So when we have a sequence of these artificial boreholes, if you were to look at it, you have a kind of a sawtooth relationship where the water goes up, it begins to drop, it goes up, it begins to drop. So we're augmenting or holding the river flow up. But that's why it doesn't provide the whole answer. The whole answer's got to come from further reductions in those licences which actually take water for public water supply.
The Environment Agency has drilled and tested 6 augmentation boreholes in the lower catchment. These were constructed as artificial springs capable of delivering a total of 15 million litres a day. The flows in the river downstream of these artificial springs is boosted to within 40 to 50% of the target flows.
What we're doing here, in addition to augmenting the river flow, is constructing a temporary river gauging station which is designed to measure accurately the flow immediately upstream of the input of augmentation water. The purpose of this is to assess the value of the augmentation water, how long it persists in the river, and to measure accurately how much gets lost through the bed of the river. These data will be fed into a computer model to assess the benefits of augmentation to the river and the effects on the groundwater system.
Following fish restocking in the early 1990s, there are signs of increasing and healthy fish populations in the upper reaches of the river around Sevenoaks. And the invertebrate species on which the fish depend appear to be stable in this area. But these improvements have not yet been found in the worst affected reaches towards Dartford, where fish and invertebrate populations appear not to have stabilised yet. Numerous fish weirs were also constructed to generate suitable flow conditions to sustain the fish stocks naturally.
What you can see here is the result of some of the work that the Environment Agency's done to reintroduce habitat suitable for the fishery. We've got sequences of artificial boards put in to recreate the pool and riffle sequence that the fish require.
Under good flow conditions like these, the current meanders from side to side. As it accelerates on the bends, it strips the silt away from the natural gravel bars, which then provide suitable spawning sites for fish.
Getting the volume of water back is one thing, but using the water in a habitat is the other. So this is the second part of the equation, making best use of that water to actually produce the habitat that's required to get the fishery back in place.
In the UK, our average annual rainfall is around 750 millimetres or about 30 inches. But of course, as we've seen recently, in some years that can vary enormously. Here at Chilgrove in West Sussex, rainfall records have been kept for more than 160 years. The readings range from 1,500 millimetres in the wettest year down to 600 millimetres in the driest, so wide variations are not that unusual. There's also a considerable difference in rainfall across Britain. The prevailing winds bring more rainfall to the high ground in the west of the country, leaving the east in a rain shadow. This rainfall gradient also applies here in the south, where in the New Forest, for example, you find an average annual rainfall of about 900 millimetres. 120 miles to the east, the equivalent figure would be little more than 600 millimetres on the Isle of Thanet. So the climate, the seasons and the geography all produce variations in our rainfall pattern. The problem, though, is that the rain doesn't necessarily fall where it's most needed, and for the urban areas in the southeast, the combination of low rainfall and dense population can sometimes put the public water supplies under considerable strain. After the summers of 1989 and 90, we all know about hosepipe bans, drought orders, and restrictions on car washes. So where does our water come from, and could it be better managed? In England and Wales, the National Rivers Authority is the government body responsible for our water environment. The NRA continuously measure every element of the water cycle. Their technicians collect data from a network of rain gauges, climate stations, river flow measuring weirs, and observation boreholes throughout the region. In the southeast, a notable feature of the landscape is the North and South Downs, stretching from Winchester in the west to Beachy Head in Sussex and east to Ramsgate in Kent. These chalk hills possess an important property. They absorb water. Almost all the rain that falls on the downs soaks through the chalk into the deeper layers, which become saturated. This layer of water-bearing rock is known as an aquifer or groundwater, and it's from such natural reservoirs that our supplies in the south and southeast are drawn. 75% from boreholes sunk into the chalk, and the remainder from the rivers. Because it's filtered through many fine layers, the water from groundwater springs is of high quality. Clear, hard, and alkaline, it's ideal for watercress growing and fish farming. The chalk streams and rivers remain cool in summer and stay relatively warm in winter, supporting a wealth of plants, insects, and animals, as well as providing a valuable source of public drinking water. During the year, the groundwater level fluctuates, as the winter rain takes some time to filter down to top up the aquifer. At points where the water table meets the surface, you find a line of springs. In winter, as the groundwater rises above the normal spring line, other springs emerge. In 1825, William Cobbett described them in an account of his rural rides through Hampshire.
In March, or thereabouts, the water begins to boil up in thousands upon thousands of places a little higher up the valley. When the chalk will hold no more, then it comes out at the lowest spots and becomes a rivulet first and then a river.
These seasonal sources, which appear and disappear as the groundwater level fluctuates, are known as winterborns because they only appear when the aquifers are at their highest level in the late winter and spring. During the summer and autumn, they disappear until the next wet season. Springs and winterborns are the visible signs of the huge natural reserves of water below the chalk downs and sandstone areas of the region. These natural reservoirs have considerable advantages over man-made reservoirs because they collect rainfall over a large area and store it at a greater depth. The water quality is also very high and requires the minimum of treatment. And unlike surface reservoirs, water isn't lost by evaporation, and using them produces no impact on the landscape. But as the population in the region grows and our consumption of water per head increases, the good management of water resources becomes essential.
We have completed phase 1 of the Darent Action Plan. Now that essentially was for Thames utilities to change their supply situation and also to reduce abstractions in the green sand section, which is the lower section of the river. They've done that, and we've also built 3 boreholes, which we call augmentation wells, that we use in times of drought. They pump water from underground up onto the river, and it flows along the surface and then sort of dissipates back into the bed of the stream. It provides a source of water in times of drought. We finished phase 1, and then we moved on to phase 2. Originally, phase 2 envisaged bringing water in from the east of the catchment, from Swanscombe, from Blue Water to the east of the catchment, by a pipeline to feed the Darent in times of drought, and that was going to be phase 2. Now, as time moved on, we found that there was more effective methods of providing that water, And essentially we have, in conjunction again with Thames Utilities, rearranged the abstraction routines, if you like. We've managed to find additional sources of water in the east that Thames Utilities can take, and we have agreed with them that they will reduce their abstraction from the pumping stations in the Darent Valley itself. And actually the target is to completely finish off with one of the pumping stations, so there will be no longer any abstractions from it whatsoever. That's our target anyway. The additional water supplies come from a paper mill, Empire Paper Mill, which no longer requires its licence, and it's a fairly large licence. Thames Utilities have taken over that abstraction licence, and they are looking at alternative sources. The quality of the water from the paper mill wasn't brilliant, so they're looking for alternative sites that they can abstract the same volumes of water to the east of the Darent catchment, and then they will not need to take the water from the Darent catchment to the same quantities that they are currently doing. So it'll be removing their source from the Darent and finding an alternative source just to the east, and that's the way phase 2 is going in operation. We have received from Thames Utilities an abstraction license application so that they can do this work, and we are currently processing that application and the variation, if you like, for the paper mills license which they've inherited. The benefits, certainly we have found that phase 1, the augmentation wells, didn't come quite up to scratch as that we would hope they would have done. They produced significant volumes for the river in times of drought, particularly 96, 97 time when we had a drought, but it didn't bring the river up to the target figures that we were hoping it would do. So we needed phase 2 to come into operation to assist with the additional water in the river. That is where we've got to at the moment. We are hoping, obviously, that the work we're doing with Thames Utilities to the east of the catchment, and also with southeast water to the south of the catchment around Sevenoaks area, that the abstraction reductions that we can achieve from those two water companies will be adequate to allow the river to flow in times of drought, together with the phase 1 activities that we've put into place.
The invertebrate species on which the fish depend appear to be stable in this area. But these improvements have not yet been found in the worst affected reaches towards Dartford, where fish and invertebrate populations appear not to have stabilised yet. Numerous fish weirs were also constructed to generate suitable flow conditions to sustain the fish stocks naturally.
What you can see here is the result of some of the work that the Environment Agency's done to reintroduce habitat suitable for the fishery. We've got sequences of artificial boards put in to recreate the pool and riffle sequence that the fish require.
Under good flow conditions like these, the current meanders from side to side. As it accelerates on the bends, it strips the silt away from the natural gravel bars, which then provide suitable spawning sites for fish.
A 3-minute kick sample gives a good indication of the kind of invertebrates present in a stretch of water. Facing downstream, hold the net on the bed in front of you to catch your sample, whilst vigorously kicking at the bed to disturb it. This should be carried out in conjunction with a manual collection of rocks and surface invertebrates.
So far, the abstraction reductions and the river augmentation schemes have raised low flows to within half of the target volumes. But as we have seen, these flows still fall short of those needed to sustain a stable river environment, particularly at a time when our climate is becoming more erratic. So, what of the future? 3 principal options have emerged to boost river flows up to the target levels. The original proposal was for further river augmentation via a dedicated pipeline from the Swanscombe area. This pipeline would transfer excess groundwater from the BCI chalk quarries, which is presently pumped to waste in the Thames estuary. It would also help to control a rising groundwater table in this area should the quarry operations cease. The pipeline would be in use approximately half the time and would deliver 15 million litres a day on average. A second option is for further abstraction licence reductions in the Darent catchment to encourage a natural recovery in groundwater levels and spring flows, which in turn would improve river flows. The third option is for further river augmentation from artificial springs built into existing water company sources. These would be combined with corresponding reductions in public water supply from the same sources. The loss of public water supply resulting from these two options would have to be offset by substitute supplies from Swanscombe and the London Ring Main. And the costs and engineering feasibility of both these proposals are currently being evaluated. If nothing more is done, there will continue to be environmental damage to the River Darent. Whatever solution is adopted, a price will have to be paid to save this unique and important part of our heritage.